Welcome to this particular module, and as we discussed in the last module that in this module we will focus on the application of the operation amplifier, and that is your clamper, right. So, what is the use of clamper and how you can use the clamper, and you may also know that clamper is also called a restorer. It also called the restorer or as a DC inserter. So, clampers are also called restorers. Clampers are also called DC restorers or inserters, and let us see that what is the quickly let us see what is the theory of the clamper, and then we move to the actual experiments, so that we can see how the signal changes when we apply some signal at the input, what is the change in the output. All right. So, if you come on the screen and look at the screen, what is done? The clamper, as I said, is also known as DC inserter or restorer. Now, these are used to add a desired DC level to the output voltage. These are used to add the desired DC level to the output voltage, right. So, if the clamped DC level is positive, it is called a positive clamper, and the clamped DC level is negative, it is called a negative clamper, right. So, first is that it will add a desired DC level to the output voltage. Whatever the output voltage is there, if you want to add DC level to it, it can add it and it will give us the new output voltage with the desired level added to the output voltage, with desired level DC voltage. Okay. So, that is why it is also called DC inserter, that is why it is called DC inserter. Right. Now, if the DC level is positive, it is called positive clamper, and the clamped DC level is negative, negative clamper. Next one is a clamper with a variable positive DC voltage applied at the non inverting terminal is shown in figure 5. So, if you see here this figure, right, the clamper with variable DC voltage, here you can generate, you see it is connected to plus VCC. So, you can generate a DC voltage and you can vary it with the help of this potentiometer, and that voltage you are applying to the non inverting terminal of the operation amplifier. Now, the circuit clamps the peaks of the input, it will clamp the peak of the input, and this is also called the peak clamper. It picks the or clamps the peaks of the input, right. It will clamp the peak of the input, and that is it is also called peak clamper. So, how it will operate, how it will work. So, let us see, all right, let us see. Now, we have if the V reference is greater than 0, the output VOA is positive, output voltage VOA across the terminal is positive. So, what we are looking at, if the V reference voltage, which is the reference voltage across this potentiometer, is greater than 0, the voltage across here right is positive, and so diode D is forward bias. So, we can write here V reference, we write here VOA, right. So, the diode D is in forward bias. Why? Because if this is more than the inverting, then you have a higher voltage across the anode and lower voltage across the cathode. That is why the diode will become forward bias. The circuit operates as a voltage follower. This circuit will operate as a voltage follower, because now we are connecting it as a to this one, and therefore, the output voltage VO is nothing but your V reference. So, when it is forward bias, your output voltage VO is nothing but your reference voltage V reference, right. Now, when a sine wave input voltage with amplitude A is applied, so here you see, so what is very important to understand, that we are applying some DC voltage at the non inverting terminal, but we are applying some sine voltage at the inverting terminal. Sine voltage applied to the inverting terminal. The diode D conducts during the negative half cycle, right. The diode D will conduct only during negative half cycle. Positive cycle this will be higher. So, negative cycle it will conduct, and positive cycle will not. Thus, the capacitor C charges through the diode to the negative peak voltage, correct. So, the capacitor will charge through the diode through the negative peak because it only conducts in negative half cycle. So, capacitor cannot charge in the positive half cycle, it will only charge in the negative half cycle, and this will charge through the diode, that is why, because diode is conducting, right. So, that is the minimum thing that I am expecting from you guys, that you know how the capacitor functions, how the diode functions, alright. So, I am assuming that when you know, then we apply the peak signal, if the positive is is not allowed, negative is allowed, right. That means in negative cycle if diode conducts, then only the capacitor can charge, right, otherwise it cannot charge. So, these are the prerequisites that you need to understand. So, I hope that now, at least now, you all know what is capacitor, you all know what is diode, because to understand complex circuits such as this, or at least a little bit complex circuits, you need to understand the basic components and the role of and the application of basic components, or the working of the basic components. So, in this case, like we have seen, the capacitor charges through diode during the negative peak voltage. When the input is positive half cycle, the diode stops conducting as it is in reverse bias, right, because if it is in positive half cycle, the diode will not conduct, because this will be higher, this will be less compared to this, and that is why the diode will not conduct, or it is in the reverse bias condition and holds the previous voltage, which was the earlier voltage, is nothing but your V reference plus V A. However, when V reference is negative, a negative peak clamping can be observed. So, if a V reference voltage, if we make it negative, then the negative clamping can also be seen. The resistor R is used to protecting the op amp against excessive discharging currents from capacitor. Now, you see whenever we use LED, we use a current limiting resistor, right, but if you use capacitor, we have to use a resistor between a capacitor and the inverting terminal, where to avoid any discharging or sudden discharge of the capacitor voltage, and it will destroy your op amp. Will destroy your op amp. So, to protect the op amp against excessive discharge currents from capacitor, when DC supply is switched off, right, we have to use the resistor, So, like I said, if the V reference voltage is positive, it can be work as a positive clamping circuit. You can see here, if I want to design this clamper, right, using the operation amplifier, using the simulation and see how the circuit will operate, then we have to again use the multisim. But before we use the multisim, let us first understand what is the experiment. The experiment is that how we can understand or study the working of an operational amplifier based positive clamper. So, if I see I can make a positive clamper, but I can also make a negative clamper. So, we will see how the positive clamper works, we will also see how a negative clamper works. Okay. So, we will not only see positive, but we will also see negative. Since we have seen in the last slide how the clamper positive negative works, let us also do the simulation in which both the circuit will work, positive clamping and negative clamping, right. So, to understand the positive and negative clamping, first thing that we have to do is to connect the circuit as shown in figure. This is the same figure that we used previously. There is a capacitor, there is a resistor that will protect the op amp from the sudden discharge of the capacitor or surge of the capacitor. Here we will apply the input signal, here we have reference voltage, here is our VOA, and here is our output voltage VO, right, and then we have seen how the circuit will operate. So, we have to apply 1 volt peak to peak at this particular input and at V1, and then we observe the output voltage VO at this particular point and note down the offset voltage. Okay. Now, we will adjust the potentiometer, we will adjust this particular potentiometer and we will change the reference voltages and see how the output waveforms would change. Finally, we can comment on the signal. This is what we always do, at the end we comment on the signal. So, to design this circuit using multisim, again we will ask our friend Sitaram who will show us how to perform the experiment using multisim.
Now, we will see the working of a clamper circuit using multisim. So, what I will be doing is that this particular positive clamper I will be designing using multisim. So, let me open multisim now, let me keep aside. So, now I will take all the components one by one. So, I will take an op amp first. So, this is an op amp that we will be using. Let me flip, right. So, what I will be doing is that I will take capacitor of 0.1 microfarad and a resistor of 4.7 kilo. So, this is a resistor I am using it. So, I am changing it to 4.7 kilo. So, one terminal will be connected to the negative, right, and the capacitor I will be taking, and the value of this is 0.1 microfarad, right. And since it is also a clamper, so we have to take a diode even in this case, but since we are constructing a positive clamper, the anode of diode has to be connected to the output of the operational amplifier, right. So, I will take a load resistance to just look into the output signal with a very high resistance value, so that it will not load your circuit, connecting in this way, and the other terminal I will be connecting it to the ground. Let me make full connections. So, we have to connect input voltage to the capacitor C1. So, what I will be doing is that I will be taking a peak to peak value of 5 volts. So, that is why the peak value I will be selecting it as 2.5 volts, and other terminal of a power supply has to be connected to the ground. I will take a ground and I will connect it now. Now, if you clearly see that in this case we have to provide a reference signal to the non-inverting terminal, right, and we should always have to have a negative feedback. So, what I will be doing is that this I will be connecting it to this terminal and to this. So, if you look into the circuit carefully, we are providing the reference voltage using a potentiometer. So, the positive terminal is connected to the potentiometer, and by using the wiper we are giving as an input to the non-inverting terminal. So, rather than using a potentiometer, even in this case what I will be doing is that I will take a DC voltage, I will be connecting the input DC voltage to the non-inverting terminal. So, as a result it is nothing but some particular reference we are providing. So, it will act as a reference to the circuit. So, in order to analyze this particular circuit, what I will be doing is I will take a probes, one at the input side, and I will take another another probe at the output side. So, the input represents green, whereas the sky blue represents our output voltage. To understand the circuit, let me run the circuit in the multisim. Now, if you see the circuit, let me change the V2 to 2.5, right. Now, if you clearly observe, in this case the green represents our input, right. So, let me enable one by one and disable one by one. So, if you see PR1 is nothing but in this case the input, and PR2 is nothing but the output. So, I am disabling PR2 so that we can see only PR1. Now, this green represents your input. So, the peak value that we are applying is 2.5 volts, peak value of 2.5. So, peak to peak is a 5 volts, right. So, it looks similar to that of what we have applied. Now, what about the negative? I will disable the input, and when you see the output signal, this is also showing the same peak to peak, because when you see the reference is minus 2.5. That means I do not need any shift, right. So, if you recall what professor has discussed in this particular lecture, right, whichever the portion that you want to clamp, whichever voltage to be clamped, that particular voltage has to be provided at the input. So, depends upon whether you are applying a positive input or negative input, that particular input signal will be clamped to that particular value, right. Since in this case we have provided input as minus 2.5. So, since the signal, the negative peak is also starting from minus 2.5 value, so it is not clamping it. Now if I slowly increase, so I will start with 0. So, since it is 0, right. So, the complete signal is starting from 0. So, that means it is shifted by 2.5 times, shifted to 0. So, let me change it to 1 volt. So, here we can see, so the starting point is 1 volt. Now, if I make it as okay, what I will do is that I will start from minus 2.5, right. So, I will also enable input to here, this is my input, okay. The maximum minimum I will make it as 8 and 8, right. Now, let me make it as minus 1.5, right. Now, it has shifted. Let me make it as minus 1, right. Here we can see minus 1. Let me make it as 0. So, the reference value is 0. So, it is completely shifting from here to top. So, it is starting from 0. So, that means we can see that depends upon what is the reference value that we are applying, the input whatever we have connected is slowly moving towards the positive side. So, that is why this is called positive clamper, right. So, if I make it 1, 2, right. So, here we can clearly understand the working of use of a diode as well as the working of the circuit using multisim. We will also understand the working of the negative clipper. So, in case of a negative clipper, what we have to do is that the diode has to be reversed. So, let me construct the circuit using multisim. So, what I will be doing is, in case of our positive clamper, the diode has to be reversed. That means, the anode has to be connected to the output, whereas the cathode has to be connected to the output of the operational amplifier. Now, if I recall, if I see the circuit, if I run the circuit, now we can see that depends upon what is the input voltage that we are applying, the complete signal has been shifted to the negative side, right. So, let me change to 3, okay, let me change from 2.5, right. Since it is starting from the peak is of 2.5, we cannot see any shift. So, above greater than 2.5, we cannot see any shift in the output towards the negative side, right. So, let me change it to 2. So, we can see that the input signal is started from 2 and going to starting from 2. So, it means that it has clamped at 2. Now, change it to 1 volt. We can see slowly shifting of the input signal towards the negative side. That is why this is called negative clamper. Let me change to 0, it starts from 0. For case of understanding, what I will do is that I will take the voltage zoom and I will make it as a negative. So, it will shift from negative, right. So, simply by changing the diode, we can understand the working of both the positive as well as the negative clamper. So, what matters here is what is the reference that we are providing as an input to the non-inverting terminal, as well as what type of how exactly the diode is been connected to the operational amplifier. That completely decides whether you are using a negative clamper or a positive clamper. So, now we have seen the simulation. We will compare the same simulation results with our experiment. So, in order to understand how exactly this clamper circuit works, positive clamper circuit, right. So, we will construct the same circuit using TI board. So, in this case, the circuit whatever we have seen, the positive clamper has been connected using this particular part. This is an op amp that we are using, only in this case we are using single op amp. So, one side of TL082, and this is the diode that we have seen, and the capacitor and the resistors, right. So, if you recall, we have connected to the positive terminal using voltage source, right. So, here at this point to the non-inverting terminal using voltage source we have connected the input, whereas in this case what we are doing is, rather than using a potentiometer, by using this particular channel, right, 0 to 5 volts channel, we have connected an input to the non-inverting terminal of your operational amplifier. So, as a result, we have connected in such a way that the negative terminal of the second channel, the negative terminal of the input voltage is connected to the input of non-inverting terminal, whereas the positive terminal of this channel is connected to the ground. So, that means that even though if it shows the input as 4.25, actually the input that the reference input that we have connected is minus 4.85. Now, when you look into the function generator, here we can see that the input that we are applied is of 5 volts peak to peak. So, that means the negative peak is of minus 2.5, the positive peak is also plus 2.5. Now, what I will be doing is that, so this is acting as a reference to us, right, and we can see using a CRO, when I slowly decrease the value from 2.5 volts to 0, we can see the shift of the signal from 2.5 to 0, right. Now, if I see the peak, the each value is of 2 volts, each block is of 2 volts. Now, what I will be doing is, since it is 4.85 and the peak, the negative peak is of 2.5, we cannot see any shift. So, that means it is not clamping because the reference value is higher. So, I will slowly decrease. So, it shows a positive, which is nothing but a negative that we are applying it. So, I am slowly decreasing. So, till 2.5 we will not see any shift of your output signal. So, when we come close to that of 2.5, I will use a fine knob. Right. So, this is 2.5, right. I have applied 2.5. Now, I will slowly decrease. In the signal, in the CRO, if you see that when I slowly decrease, right, the value started clamping towards the positive side, right. By looking into this particular point, we can clearly see that it is started clamping. The positive is of 2 higher when compared to the negative. Now, let me decrease it. So, you will understand if I decrease, if I increase the value, actually speaking you are decreasing it, right. Here you can see it was moving towards upside, right. So, if I would have connected to the negative side, so if I connected the positive terminal of this particular channel input to that of a non-inverting terminal of an operational amplifier, we would have seen the clamping of the signal towards the positive side, right. Now, we will show you the working of the negative clamper. So, in case of understanding about the working of a negative clamper, what we have to do is that we have to simply reverse the connections of diode. So, this is the diode. So, what I will be doing is that I will be simply reversing the connections. So, let me switch off the circuit and this value, I am reversing the diode and connecting. The output probe here. So, since we are discussing about the negative clamper, I will also change the reference value, the positive to the positive input and negative to ground. So, this is the positive input, this I will be connecting it to the non-inverting terminal of an operational amplifier, whereas the white one is ground, I will be connecting to the ground. Right. Let me switch on the supply, right. So, if I see that the input peak to peak in this case is of 5 volts, right. So, that means the peak value is of 2.5. So, since the input voltage is greater than 2.5 volts, you cannot see any shifting of your, that means clamping of your input signal towards the negative side. Now, if I slowly decrease the value from 2.5, if you observe that it will start shifting towards the negative side, right. Here we can see the shifting towards the negative side.
So, the point is, what I was discussing is that you can perform the positive clamping, you can perform the negative clamping. The only thing is, when you perform the positive and negative clamping circuits, you need to understand what reference voltages you are given and whether the reference voltage you are giving to the non-inverting terminal of the operation amplifier are correct or not. If you do not apply a correct voltage, or if you do not connect a correct load resistor to the circuit, you will not get the output as desired. So, you can make positive clamper, you can make negative clamper just by changing the reference voltage at the non-inverting terminal. So, I hope that you understood the role of the clamper and how the positive and negative clampers can be designed and can be used using multisim. So, I will see you in the next class. Till then, you take care.